Welcome, everyone. Thank you all for joining us today for Sustainable Conservation's Voices from the Field webinar series. We want to give a thank you to our webinar sponsors. That includes Spotswood Estate Vineyard and Winery, Environmental Science Associates, and Holland and Knight. Thank you for supporting our webinars and sharing Sustainable Conservation's vision of a climate-resilient California. I am Shayan Kaveh. I am Sustainable Conservation Science Communicator. For those of you who don't know us, Sustainable Conservation is a California nonprofit dedicated to the collaborative stewardship of California's land, air, and water for the benefit of nature and people. Before I introduce our speaker and we look ahead to this winter, I want to take us back to the winter of 1861. That winter, the Great Flood of 1862 began. This event turned the Central Valley into an inland sea, 300 miles long. It remains one of the largest floods in California's recorded history, and the native people who have lived with these rivers for centuries saw it coming. That December, native Nisenan families living near what is now Marysville in the Sacramento Valley packed up and moved to the foothills. There was no storm yet, but they had seen the signs. A local newspaper, the Nevada City Democrat, reported it this way in January 1862. They wrote, "We are informed that the Indians living in the vicinity of Marysville left their abodes a week or more ago for the foothills, predicting an unprecedented overflow. They told the whites that the water would be higher than it has been for 30 years and pointed high up on the trees and houses where it would come. As they live in the open air and watch closely all the weather indications, it is not improbable that they may have better means than the whites of anticipating a great storm." Their traditions held the memory of waters that rise far higher than anything settlers had ever seen. And although the winter of 1862 was not an El Nino winter, there were signs of a coming storm that science has since corroborated as a winter slammed by a series of California's infamous atmospheric rivers. I share that story today because we are once again being handed a warning. This time, instead, it comes from ocean buoys, satellites, and forecast models, and they are pointing with remarkable confidence toward one of the strongest El Nino events ever recorded. It has already begun. The question is whether we'll prepare better than 1862, whether we treat the water that may be coming only as a threat or also an opportunity for our aquifers, our ecosystems, and our farms. There's no one better to help us read today's signs than Dr. Daniel Swain. Dr. Swain is a climate scientist with UC Agriculture and Natural Resources and UCLA. He is the author of Weather West blog and one of the clearest voices anywhere on California weather and climate. Daniel, welcome back. We're so glad to have you.
Thanks for having me back. It's good to be here.
To get us started, connecting to this winter of 1862, we're hoping to just get a sense of where we are today. How does the present compare to 1862 in a holistic sense? That's in terms of both flood risk and population exposure and preparedness for our ecosystems and different land uses.
Yeah, I think this is an important question. It's a big question. There's like five different major sub-questions embedded within it. But I think that there's a few pieces of it that I'll sort of focus on, which is to say, first of all, as you mentioned, the Great Flood of 1862 did not occur, to our knowledge, in an El Nino year. And although we don't have as detailed information about what was going on in the remote subtropical Pacific, where no people presumably really were spending much time in 1862, to the best of our knowledge, that was not what sort of led to this particular extreme flood event, which as a point I raise to just emphasize the fact that it doesn't take a very strong El Nino event to produce a really big flood in California. We know that's true from history. We know that's true from more recent anecdotes in the 20th century too. But I also wanted to point out that this does not we can't take that so literally and so narrowly as to infer that a very strong El Nino event does not still increase the risk of an event like that one, even if that particular event didn't in fact occur during an El Nino event. And so this is a point that, I'm raising first just because it directly connects with some of the discourse that I've heard recently surrounding this current event, which is that, well, not all El Nino events produce floods. Most of our floods aren't associated with El Nino events. And so, therefore, we shouldn't worry about this one. And I think if that's the takeaway for some folks, it's one I really want to try and push back against because I really do think we need to be taking this one quite seriously because it probably is going to increase significantly the risk of a big flood in California, while simultaneously it is still true that El Nino is not the only way that California sees big floods. We can certainly see them otherwise. And the corollary to that is that there's no guarantee that there'll be significant flooding this winter. We could get lucky and have a fairly wet winter where everything is nice and spaced out, and we get a lot of water without a lot of problems. Wouldn't that be nice? But I think that, in terms of talking about balancing risks and benefits, I think that's an important part of the conversation. So point number one, 1862 was not an El Nino event, but it doesn't mean that El Nino doesn't increase the risk. Point number two is that the climate today is warmer than it was in 1862. And this is a significant difference. The global climate is now right around 1.5 degrees Celsius, which is now over 2 degrees Fahrenheit warmer than it would have been in 1862. And that might not sound like a lot, but if you think about how the atmosphere can hold exponentially more water vapor with each fraction of a degree of warming, the scaling is close to about 7% per degree Celsius. So if you multiply that 7% times about 1.5, we're living in a world where the air can hold more than 10% more water than it could back in the 1860s. And so that starts to become a bigger deal. And this year, with our big El Nino event, global average temperatures are going to be closer to 1.7, 1.8 degrees Celsius above that 1862 level. So temporarily, El Nino is going to raise the ceiling on how much water vapor can be there even farther. We're going to be closer to 20% more water vapor. So point number two is we're living in a warmer world and one where the capacity of the atmosphere to generate extreme hydroclimate events, be they floods or droughts on the other end, is substantially higher than it used to be. And then the last piece of this I just wanted to address in the opening is just that, California itself, from a human geography perspective, is a very different place than it was in the 1860s when the state was home to something on the order of some hundreds of thousands of people, where today it's a place where 40 million people live. And, the population today living in California floodplains is significantly larger than California's total population in the 1860s. On the other hand, we also have a much more developed era of water allocation and capture and flood protection systems, the built infrastructure, the dams, the reservoirs, the levees, the flood control, the active systems, as well as the passive systems. Those the YOLO bypass, the aquifer recharge basins, all of these pieces of infrastructure, whether they're the steel and concrete type or the nature-based type, that were not really there in the 1860s, certainly not to this level. There were some small earthen levees that were literally more or less just piles of dirt and unconsolidated rock. Some of those levees, by the way, are the very same levees we still have unimproved in the Delta today, which is a point maybe we can return to. But the point is that we are both more and less at risk than we were in the 1860s from a human geography perspective. There are way more people in potential harm's way. There are way more assets and infrastructure in potential harm's way, but also we do have modern flood control systems, which up to a point at least do buy us a significant margin that didn't exist in the 1860s. And so it's sort of a double-edged sword there. There's more at risk, there's more protected, the climate is warming, and will likely be a record-breaking El Nino event this year to deal with.
Before we jump into more questions about what El Nino is, you just mentioned the atmosphere's increased capacity to hold moisture as the temperature increases due to climate change. Last time you gave us this really strong visual analogy of the atmospheric sponge. Can you remind our audience, or for those who weren't here last time, what the atmospheric sponge is?
Yes, yes, this is still something I'm pleased we convinced the editor to allow us get in as many words into the peer-reviewed published literature. But this is essentially this notion of the expanding atmospheric sponge, which is a hopefully tangible analogy that my colleagues and I have been using to describe the practical effects and the general nature of the thermodynamic changes that are unfolding in the atmosphere and how they relate to things like drought and flood and wildfire risks. So the basic idea is this. Imagine, if you will, you have an ordinary kitchen sponge. It's dry to start, like a brand new sponge right out of the package. It's on your kitchen counter, and it has some capacity to hold a certain amount of water. Maybe you spill a glass of water, you soak it up with the sponge. Um, and so, therefore, the sponge, before it gets wet, has some capacity to absorb a certain amount of water that is fixed, right? You can saturate a sponge up to a certain point, and then it's fully saturated. It can't soak up any more water. You wring it out over the sink, it yields a certain amount of water, most of the water that was in it. Now imagine you have a comically oversized kitchen sponge, like one that's like 10 times larger than a normal sponge. Well, this one's going to have a much greater potential to absorb water. Certainly, it'll absorb that glass you spilled. Maybe it's going to absorb a whole pitcher that you've absorbed that you've spilled on the counter. And therefore, now if you use the comically oversized sponge to soak up a bunch of additional water and then squeeze it out over the sink then now it's going to yield a lot more water. This analogy is the way to think about the warming atmosphere in a warming climate, in the sense that a warmer atmosphere can hold more water vapor, and so when it is saturated and when conditions are favorable for precipitation, it raises the ceiling on how high the precipitation intensity can potentially go. But the reverse is also true, and this is one of those rare analogies where actually the caveats also hold in the analogy as they do in the real world. A comically oversized but completely dry kitchen sponge holds no more water than an ordinary sized one, which is to say zero. And yet its capacity to absorb water remains much higher, but the actual amount it has contained within it remains the same unless you offer it more water to absorb. And this is why, on the other side of the spectrum, the capacity to evaporate water grows ever higher because with that larger sponge, you're going to more readily evaporate that water out of the landscape, out of bodies of water, etc., etc. So, by virtue of the same thermodynamic coin, or the same sponge, if you will, the atmosphere's capacity to both absorb water vapor, um, evaporate, and to be wrung out, in other words, precipitate that water, are both increasing. And so this leads to an accelerated hydroclimate cycle. It turns out the basic science behind this is actually pretty fundamental in chemistry, physical chemistry, dating back to the 1800s. So long before complicated numerical computer models and climate models, this was something that was known through the Clausius-Clapeyron relationship with science that was done experimentally, not long after the Great Flood of 1862.
Fascinating. So as the temperature increases, the extremes have more potential to be more extreme, it sounds like, with this sponge.
Yes, that's exactly right. And then maybe the key part, and this is especially relevant to California, is that it doesn't necessarily mean that this tells us what the average is going to do. It doesn't tell us that we're going to get wetter on average or drier on average. The expanding atmospheric sponge primarily tells us exactly, as you mentioned, what happens in the outermost tails of the statistical distribution. So the wettest wets and the driest dries both escalating for the same underlying thermodynamic reason.
Hmm. So maybe focusing in on this year, not this larger context anymore, let's start from zero. El Nino has become a pretty common word in most people's lexicon, but what actually is El Nino? What's happening in the atmosphere, and how does warm water thousands of miles away change the weather here in California?
Yes, yes, and this is the subject of some other easier to dispel misconceptions, so might as well start from the beginning. El Nino, simply put, is a temporary, unusual warming of the equatorial Pacific Ocean waters. That is the entirety of what El Nino is. The eastern equatorial Pacific Ocean is warmer than it usually is. Definitionally, it has nothing to do with anything happening directly in California. This is something that happens thousands of miles away from California between the Galapagos Island and the coasts of Peru and Ecuador. But the challenge is that it does, in fact, have these profound global climate implications. El Nino as a process, scientifically speaking, in terms of the Earth system, what it's really doing is it's acting as a bit of a thermostat. So there's that hot tropical sun beating down. on that ocean for much of the year, accumulating heat, subducting it below the surface, and then every few years ago or so, every 2 to 7 years, something like that, on a semi-recurring cycle, this warm water sloshes eastward, and then you essentially the ocean transfers a lot of its excess energy to the overlying atmosphere. So El Nino is a mechanism by which the tropical Pacific Ocean dumps a bunch of excess heat into the atmosphere. So, in a sense, it is good. It is necessary that the ocean occasionally has this process by which it can dump heat. But the problem is, of course, in doing so, it all enters the atmosphere where we all start to notice it. So, it enters the atmosphere in the tropics, and then that excess heat and energy starts to spread all around the world in the 6 and 12 months that follow. That's where we are right now. The reason why it affects global climate well beyond the tropics, in California specifically, is El Nino profoundly alters two things. One is the position of these tall tropical thunderstorm clouds that sort of act as ripples in the global atmospheric pond, which sort of the ripples from which kind of affect the upper level wind patterns known as the jet stream, these storm track pattern, essentially thousands of miles away in almost every direction. So it has this indirect effect on storm tracks that can lead to, in some regions, droughts where you shift storm tracks away, and in other locations, floods where you start to shift a storm track persistently over the same location. But the other thing it does is it temporarily raises global temperature. The entire global temperature baseline for the next year or so will be significantly elevated by somewhere between about zero point 0.3 and zero point 0.5 degrees Celsius, which might not sound like a lot until you realize that all of the impacts of global warming that we're talking about are occurring at a long-term warming of about 1.5 degrees Celsius. So we might see, something like a quarter or a third temporary addition to global warming just this year on top of the already warming Earth. And so that, can sort of put an exclamation point on this acceleration of the hydroclimate cycle that we're already seeing. And so that's generally true. El Nino puts more heat, more moisture, more energy into the global atmosphere. It accelerates the whole global hydroclimate cycle. And then in addition, in certain specific regions, it shifts the storm track that results in more of a zero sum type situation where some places get drier, some places get wetter.
Fascinating. And you mentioned the cycle. I believe you said it lasts typically 12 to 18 months. Is that how long the El Nino phenomenon generally goes on for?
Well, it depends. So El Nino is part of a broader oscillatory pattern known as the El Nino Southern Oscillation. This encompasses La Nina, so the cool phase, as well as El Nino, the warm phase. It is actually semi-periodic. People often talk about climate cycles, but they're not really cyclical at all. But El Nino and La Nina actually are at least semi-cyclical. They have some predictable periodicity on the order of something like between 2 and 7 years, and for reasons that are physically understood. What we tend to see is that El Nino tends to last somewhere between like 9 to 12 months, something like that. So usually less than a year. This event developed this summer, depending on how you define it. It developed as early as June, or maybe it hasn't developed yet if we need the 3 or 4 month sustained definition. But it will have developed in summer 2026 by anyone's definition, I think, and it will probably persist through probably the late winter, maybe the early spring. So we're probably right in that classic sort of 9 month window for El Nino before we might swing back on the opposite direction next summer. If we do have a truly powerful El Nino event this year, which looks quite likely, it's more likely than not the pendulum will then swing in the opposite direction next year as the pendulum swings in the other direction and as the tropical Pacific has sort of exhausted its internal heat supply for the time being.
Interesting. Yeah. And you've written that this El Nino is unprecedented in its intensity, which makes me curious. How much should we attribute El Nino itself and perhaps its frequency to climate change?
So El Nino and La Nina, and so collectively the broader oscillation, is itself a natural process that's been around for at least hundreds of thousands of years and perhaps millions of years, really for as long as the continents and the oceans have had their current spatial configuration. But El Nino and La Nina, they do interact with climate change. In the most obvious way they do so is that the global oceans are getting warmer, and we define El Nino based on how warm the eastern equatorial Pacific Ocean is. So it might stand to reason that El Nino is getting more intense because the ocean temperature departures from average are getting more intense in this region. This is a tricky thing because El Nino kind of has two different influences. One, as I mentioned, is sort of based on the absolute temperature, where this definition makes sense. The hotter it is, the more heat comes out, the more evaporation there is, the greater the intensification of the global hydrologic cycle. So in that sense, it does matter, the absolute temperature, how warm it is. And there is already a clear climate change signal. But there's another argument to be made that one of the reasons why El Nino shifts storm tracks is because how it shifts the spatial pattern, the blobbiness, if you will, of warm and cool water in the Pacific. And it is in particular the fact that the eastern equatorial Pacific becomes much warmer even than the adjacent, already warm tropical oceans that exerts a lot of the storm track influence. So if we want to understand it from that perspective, we actually need to subtract out the long-term mean warming trend to understand for lack of a better term, the relative warm blobbiness associated with El Nino. Very scientific term there. And so there are different metrics to measure El Nino. One is but known as the relative Nino index, which does in fact do exactly as I just say, subtracting out the global warming effect. This is not an attempt, as some have characterized it, to hide the global warming effect. It's just something that we actually need to do to fully understand the physical interpretation of any given event, to sort of make an apples to apples comparison of the present event to historical events that occurred in a cooler climate. So that's one valid and interesting definition. By that metric, this event is tracking very close to, thus far, the most extreme El Nino events in history. So 97, 98, 82, 83, it's right up there, exceeding, by the way, 2015, 2016 by a significant margin. If we instead, though, go with the absolute measure where we do not subtract out the global warming effect, and that has other valid uses too, because it does actually matter in absolute terms how warm the tropical Pacific Ocean is in terms of the total amount of global heat, the total acceleration of the hydroclimate cycle. This event is already blowing all other historical events out of the water. This event is already record shattering. So essentially, by the much more conservative metric, it's tied sort of with the most intense event we've ever seen already, and using another metric that is on its own right appropriate for other purposes, but needs some cautious interpretation, it's already record breaking. But either way, the forecast for this fall and winter is that regardless of which metric you use, and this is what's quite extraordinary about it, we will very likely experience a record-breaking event even if we subtract out the global warming effect by the time we get to the fall and winter. So this is a genuinely extreme El Nino event that is expected to become even more extreme in the weeks and months to come. The only other thing I would add is that there is some evidence that El Nino will probably occur, or at least the most intense El Nino events, and this is what's interesting, more frequently in a warming climate. Not necessarily more El Nino overall. In fact, there may even be fewer El Nino events in general, but those that do occur might be more likely to become extremely intense. And it is notable that we've really only had strong to very strong El Nino events in the past couple of decades. So we have seen a trend, believe it or not, toward fewer but more extreme El Nino events. This year's event will really put an exclamation point on the extreme part of that equation.
That's quite fascinating. I'm not going to ask this question, but I'm curious how much of that is partly due to our better ability to track these things versus relying on records. And it's quite fascinating that the most extreme events have occurred in the most recent decades, also, regardless of climate change. You're saying how this El Nino is already here and strengthening fast. What are the signs you're watching for right now, and what still can't be known about this El Nino this far out?
Well, as we had this conversation in late August, the train has largely left the station with this big event. I mean, it's already a huge event, and it's going to get bigger. There is a certain amount of thermal inertia, or even literal physical mass based inertia in the system. The very warm water in the tropical Pacific Ocean is quite literally sloshing eastward with its own momentum. This is part of what happens during an El Nino event of this magnitude, and so we're already guaranteed essentially to have a very strong event. I mean, kind of the low end of what might happen this year is a top three on record El Nino event. That's the low end of what is plausible at this point. The most likely outcome is a record-breaking event, and the outlier upper outcomes are just bonkers record-breaking event that exceeds historical records by enormous margins. I mean, that's what we're looking at this year. The numbers are pretty stark. I don't really see any way this falls apart at this point. It's there. It's getting stronger. Every single physical indicator is screaming that it's going to get stronger still. Now, importantly, this is where we get to the global hydroclimate impacts and what might or might not happen in California. All of this does not guarantee that California is going to have an extreme winter, because there's a bunch of, I liken it to a Rube Goldberg machine, for those who know what that kind of machination looks like, or a daisy chain. I joke that this is sort of generational, which of these expressions makes any sense to people, but I think the key is that there are multiple links in the chain between a record-breaking El Nino event and then what might or might not happen in California. And although I do think the odds are pretty heavily stacked in the direction of a winter that could be pretty dramatic, frankly, in multiple respects in California.
And considering that, predictions are suggesting it will be a pretty extreme winter, although we can't say for sure. What do you think of California's current water infrastructure with this oncoming event? Are we ready for this type of rain? What can we do to take advantage of it?
Well, let me first back up and sort of emphasize what I think might or might not happen this winter and how we know this. The number one, I think, concern I'm raising right now is the coastal flooding impact. And that's partly because it will affect a lot of people, but also because it's essentially guaranteed. This is one aspect of a very strong El Nino event that we're very unlikely to somehow miss out on. Which is to say, this winter, the ocean itself will be higher than it will be in a typical year because El Nino can send about a foot of water northward along the coast. It doesn't literally send tropical water to California, but it sort of induces this very broad, gradual wave. It's not like a tsunami. You don't have to run away from it or something on the beach, but it is this gradual rise that will culminate in the ocean being about a foot higher than it usually is. And that doesn't sound like a lot until you realize that historical sea level rise from global warming is on the order of 8 to 10 inches in California. So it's essentially like saying this winter we're going to temporarily double the amount of sea level rise we've already experienced, and it will be sustained all winter through high and low tide cycles, including king tides, in the same winter when we're more likely to see stronger storms, more frequent storms, more low pressure systems that could cause very large waves along the coast, very energetic waves that could cause temporary storm surges in San Francisco and Humboldt and San Diego bays and places like that, dry some water on shore. So the problem then is that this winter we have a significant likelihood of seeing coastal flooding that is right up again at the top levels that we've ever seen. Think, 1982, 1983. We saw some pretty big coastal flooding last year. Think about levels that are at least that high. And if we get unlucky and we get a storm or during a king tide event or something like that, we could easily see record-breaking coastal flooding this year because of the combination of the historically strong El Nino, temporarily elevating sea level, the cumulative effect of human-caused climate change and sea level rise, which is always there lurking in the background, making the ocean a little bit higher every year, and the increased likelihood of storm surges from El Nino amplified storms, which then brings me to the other point that I wanted to make, which is about the storms themselves. There has been a little bit of, I think, of confusion in California, and so I kind of want to set the record straight. Historically, there was maybe a little bit of an overstatement that El Nino equals wet in California, and it's rarely that simple. El Nino is only one of many climate influences that can affect California precipitation. And if you do a very simple correlation analysis, you find that the Niño 3.4 index is only weakly correlated with California precipitation. You can find lots of weak to moderate El Nino years that were dry and a lot of La Nina years that were wet and vice versa, which is fair enough. But the problem is that relative type of analysis has been taken to mean that very strong or historically strong El Nino events therefore also don't exert a really clear influence on California climate. And I really want to take a moment to dispel that myth because there is very strong evidence that strong and very strong El Nino events, and in particular, very strong events that are structured the particular way that this year's event is structured, are probably the single strongest indicator of a wet California winter that exists. There is no other physical process on Earth that we are aware of that would give us this much advanced knowledge of a strong shift, tilt in the odds towards a wet winter in California. And not just a wet winter, but potentially even a very wet one. This still doesn't mean one to one that we're going to see huge floods in California. Many of California's major floods, as we were talking about with the Great Flood of 1862, did not even occur during an El Nino event at all. However, if we sort of go through the logical concatenation of what causes California floods, well, big individual storms falling on saturated soils, pretty much. And we talk about what an El Nino event might bring to California and what this particularly very extreme El Nino event might bring this winter, which is to say, uh, elevated likelihood of a wetter than average winter. Check that box. That's soil saturation. It means that, whatever rain falls as you go later into winter is more likely to be falling already on saturated soils, rivers running high, reservoirs already relatively high. Then you ask, okay, does it increase the likelihood of individual heavy precipitation events? And when you talk specifically about very strong events like this one, the answer is yes. Then you might ask, okay, is there a difference between Northern California and Southern California? And in general, it is true that the relationship with El Nino is stronger in Central and Southern California than it is in Northern California. But again, there's a big however here because this is no ordinary El Nino. This is probably going to be the strongest one we've ever observed, and by a significant margin. There is a lot of evidence that the El Nino relationship does, in fact, extend farther north to encompass essentially the whole state, including the west slope of the Sierra Nevada, during the very strongest events, again, like we are expecting this year. All of that is to say, the weakest link in the chain is between a record-breaking El Nino and California winter precipitation. There's no guarantee, but there is a profound shift in the odds towards a wetter than average winter and perhaps a very wet winter that produces elevated flood risk. We can't guarantee those things, but all else equal, there is probably no single factor in the climate system that could predict a more substantial shift in the risk in that direction than what we are currently seeing. And as a scientist and a risk communicator, I think it's really important to understand that even though we can't speak in absolutes, this is a 10 out of 10 in our ability to predict future conditions in the winter. And this is right up at the top end of that scale.
10 out of 10 is pretty intense. And at the beginning, you mentioned some of these earthen structures, the levees and the delta, and what is at risk with the chance of coastal flooding. Can you tell us a
Yes,
little
yes.
bit
I
more about
realized I
that?
didn't quite answer your question from the last round of sort of about, are we prepared infrastructure wise? I think, and the answer is in a lot of cases, has less to do with this specific El Nino event. It has more generally to do with the general state of preparedness surrounding either inland freshwater flooding or coastal saltwater flooding, or a mix of both of these things. We have a lot of the state where actually there's dual infrastructure. So thinking about the delta levees, a lot of the flood control in the lower Sacramento, lower San Joaquin. I mean, you have tidal influences all the way into Stockton, for example. So a lot of that infrastructure, depending on the year, depending on the season, is actually mainly holding back saltwater versus freshwater. And there's this push and pull, this tug of war. I mean, this is one of the big challenges about water use, especially during droughts. Is you have that salt water that makes it further inland during droughts, and you have fresh water that pushes the saltwater lens westward into San Francisco Bay when there's a lot of fresh water coming out of the mountains. You know, Sea level rise? No, we're not prepared for the long-term sea level rise, and this year is going to be like a preview of 20 or 30 years in the future in terms of sea level rise. And so we will get a brief, it won't be like this every year for the next 30 years, but this year will be kind of like an early unwanted preview of what sea level rise could be like in a couple of decades. And no, I don't think we're fully prepared for that. I expect this coastal flooding to be highly disruptive. There could be major highway closures that last even for hours or days on multiple occasions. People's homes very well may flood along the coast because the water level, and not just the oceanic coast, but also the coastally connected bodies of water, San Francisco Bay, and its estuaries, Humboldt Bay, San Diego Bay and its estuaries, really anywhere within anything that's within about 4 to 5 feet of sea level and is connected to something that's connected to the ocean, even indirectly, is potentially at risk in a year like this one. And we know, that the just in the San Francisco Bay Area, that preparing our infrastructure for what is considered to be the low to medium end of the projected range of sea level rise is something like a 50 to $100 billion proposition. So no, we're not ready for that. Inland freshwater flooding, I think, the picture is mixed. Obviously, we have a much more sophisticated infrastructure than we did, in the 1860s, and even more sophisticated than we had in the 1950s. So things have certainly become more rigorous. And there has been some investment in improving the reliability of some of our life safety critical flood protection infrastructure. We've seen some weaknesses in recent years. You all know that every big flood event, there's a levee failure of some magnitude. Sometimes they're very inconsequential, sometimes they're a huge deal. We all know what happened on the spillway on Oroville Dam back in 2017, the near catastrophe there. And that wasn't the dam itself, even. It was an adjacent auxiliary structure. And nonetheless, it could have been a real disaster that was narrowly averted somewhat by chance. I think that, I'm less worried about Oroville Dam because there was a lot of focus paid to that, and I think we probably fixed that problem. I'm assuming it's by all accounts that problem, that particular problem is now well fixed. But where are the other gaps? I think that the recent experience has allowed us to be a little more circumspect about where some weak links in the chain probably were, which is good. Now there is there's been a fair bit of effort to armor a number of levees and rebuild or re-strengthen or often offer sort of secondary emergency spillway opportunities for some of these major dams. That's like the concrete and steel type infrastructure problem. And we do need some of that. I mean, people live where they do. We built our cities and our infrastructure where we did. And in those places, I mean, I think it's very reasonable to say, we don't want a levee failing and flooding downtown Sacramento. Like, obviously, that would be a bad outcome. And so we need to do what we can do to make sure that that's as uh, low a likelihood as we can possibly get to. On the other hand, we are learning also, and this has sort of been the lesson the last 20 years in flood management and in river science is that you can't concrete and steal your way out of all these problems. And that if you don't also give rivers room to roam, give rivers room to do their thing when they want to, which is to say to flood, essentially, which is a natural process. Rivers have the course that they do, the shape that they do, the characteristics that they do because of all of the geologic scale floods they've had over centuries and millennia, then we're actually overly constraining the solution space and actually setting ourselves up to be at greater risk. So if we don't embrace things like restoring floodplains, if we don't embrace things like allowing controlled flooding of agricultural lands or open spaces that we pre-designate as sort of places that won't be greatly harmed by being inundated for some days or weeks at a time, if we don't also prioritize groundwater recharge, all of these things, are things that both help with the health of the ecosystems that they're occurring within, but also uh, ideally sort of are co-beneficial in the sense that they also help us manage our flood risk because they give us another option that isn't just more dams, more concrete, more steel, partly because that's not ecologically desirable. That's not great for the environment to continue to move in this direction if we must build our way out of everything, but also the pure cold hard math of the dollars spent, it's a lot more expensive to build these enormous infrastructure projects, and it's really expensive if you invest in them and then they're not adequate because they fail because we relied on them too much. And a lot of these nature-based solutions are also appealing because they often involve, they're also often less expensive, and they often are a really helpful adjunct to the systems we already have in place. And so I think that all of this is although may seem a little pie in the sky, California has been increasingly adopting, or at least beginning to adopt more of these nature-based solutions. There are a number of pilot projects right now, especially in the Central Valley, that you've talked about in the past. I think the challenge is we're sort of halfway there. We've talked a lot about it, which is good because the first step is always talking about these things and acknowledging their importance, which we weren't really doing 15 or 20 years ago. So that's progress. There's pilot projects. That's the next step, which is also real progress. But we still haven't implemented these things at this scale. Either the let's make sure all of our, you know, hard infrastructure is fully up to snuff, and we really got to make sure that that the levees are doing exactly as and performing exactly as we expect in a warming climate and with higher and higher flood potential. And also, that these nature-based solutions need to be implemented not just in these pilot project forms, not just at small scales, but in a much grander sense to really move the needle here. So we're moving in the right direction, but we're not there yet. And so we're in this interesting moment where the right conversations are being had, the right pilot projects are being run, but we're still potentially quite vulnerable to a large flood. And so this is sort of that tension that exists, I think, in 2026.
Yeah, that's exactly where sustainable conservation is trying to sit, hoping to scale some of those solutions. And there's a lot of things that are out of our hands that bigger fish are going to have to fry. But we appreciate you sharing some insights on that. I have one last question before I ask you a final closing question, but we are experiencing this historic event after last winter's historically low record snowpack in the American West. And I'm curious, does El Nino have any potential to shift the balance between rain and snow?
Well, so this is what's interesting is that a very strong El Nino event might give us a little bit of relief in the lower Colorado Basin in particular. So it might result in a wetter winter in the lower basin, which of course is a lower elevation basin where less of the precipitation is coming from. So it is less helpful maybe than it would be if the upper basin were likely to be wet. But the other reality is, El Nino might shift winter temperatures by half a degree or a degree in the Colorado Basin. But remember, winter temperatures have already risen by several degrees historically. And so we're getting to the point that in terms of temperature, global warming now has a larger influence than these swings between El Nino and La Nina in terms of temperature. El Nino and La Nina still matter for precipitation year to year. But, it's getting harder and harder to have great snow years, in lower elevation regions. At higher elevations, that elevation buys you decades of warming, so that the highest elevations are still cold enough that if there is a lot of precipitation, that it usually does fall snow. Last year was a different story. It was just ridiculously warm everywhere. I mean, it was in the 80s at the top of the Rocky Mountains in March, but um, this coming winter, that we're probably not going to see a repeat of that with an active Pacific storm track. So it almost certainly won't be as warm as last winter, which is good. And at least the lower basin will probably be wetter than last winter. So whether that translates to a good snowpack or not, hopefully it will at least translate to more precipitation, even if a lot of it is rain. In the upper basin, I think at least it won't be as warm as last year, and so what precipitation does fall. Well, I'll put it this way, we probably will not have as bad of a snowy season this year as we did last year, and that's less a statement about my optimism about this year, but more just that the pattern last year was so unusually extreme in the opposite direction that we're probably not going to see a repeat, at least not this year.
That's something I'm hopeful for in that regard, at least. Great. Before we switch to audience Q&A, I just want to give you the opportunity. If there's one takeaway you want the audience to take from this conversation, what would that be?
Um, Well, I think it might actually be aligned with my sort of my opening statement response to the 1862 question, which is that, you know, California is a different place than it once was in terms of, we have more people in harm's way. We also have more flood control systems in place than we did back then. The climate itself is a different climate than it was, 150 years ago. It's warmer, it's more, it has a greater propensity to yield both large floods and large droughts. And we've seen, plenty of both globally. In California, we've been sampling more from the drought side than from the flood side in recent decades, although there have been some notable exceptions. And looking forward, it actually looks like we're likely to have some really big flood events in the mix as well as the climate warms. Whether or not this year ends up being one of them remains to be seen. Although, and this would again be my third final echo, we are going to experience, at a minimum, a very strong El Nino event this year, and very possibly the strongest on record by a considerable margin. That is genuinely a big deal and does significantly up the odds of a wet winter, of severe coastal flooding and possibly also of significant inland flood risk as a result of heavier than average precipitation. That's the view looking forward from August. I would be fairly surprised if that view changed in September or October. At this point, I think we're kind of in for the ride, and we will see. We will, in retrospect, you'll be able to judge that outlook, I guess, by the time we get to March and April next year. But I think that right now and for the foreseeable future, that's probably where we're headed. And, that does not guarantee that there's going to be terrible floods or anything like that. That's, we again, we could get lucky. It could be all spaced out. It could be a great winter in that respect. But we have to be able to sort of walk and chew gum. We have to be able to think about both sides of this, much as we have to think about, the traditional steel and concrete infrastructure as the same moment we think about the nature-based infrastructure and how they can be synergistic and how in some cases, the nature-based infrastructure can take over for the other or absorb the excess, if you will, or we can kind of envision a system where we don't have to just talk about one side of it, but we can really think about the whole thing as a system, as something that is part of an integrated whole.
Definitely. I mean, from the Sierras to the Delta, there's kind of one watershed that rules most of California, it seems like, and paying attention to both ends is so essential. In our Q&A, we have quite a few questions about wildfires. And so people are curious whether the risk of wildfires related to warmer temperatures in California this fall, or whether that might lead to the onset of more delayed rains, or people just want to know your thoughts on whether we should expect a more intense fire season coming up this year and how El Nino might impact that.
Yeah, well, for this current fire season, we're already a good part of the way through it. Uh, I don't necessarily think it tells us a great deal about how it's going to wrap up over the next couple of months. We have some active fires now. Southern California is experiencing a near record-breaking heat wave at the moment, so some fire activity is really heating up, so to speak, down there right now. Um, other parts of the western U.S. have had a record-breaking fire season. California has not. The Pacific Northwest has. The Great Basin has been really active. The Rockies have been really active. So California is actually a bit of an anomaly on the quiet end, knock on wood, so far this season, which is largely consistent with the seasonal prediction that this year's would not be a notably historically active fire season for reasons that, relate to the lack of drought right now in California as compared to the rest of the country and things like that. So I think don't be surprised necessarily if the fall is somewhat unremarkable in terms of precipitation. Now, a big El Nino event does not necessarily mean that the fall will be super wet or that there'll be an earlier onset for precipitation. So we could still well have an active, fire season through the autumn. Where it really starts to change things is once we get to November and December. I think that's when the odds of things getting much wetter go way up. And so, for example, one thing I think that would be very, very almost vanishingly unlikely this year is a big uptick in winter fires. So, like the January 2025 fires in Southern California, those almost certainly event like that couldn't happen this year. I'll never say never, but I would be astonished if those kind of preconditions were in place this January. So that's one thing that we probably don't have to worry about, at least as we get into January. The more interesting question about fires probably is actually looking a season ahead to next summer and fall, because what we'll probably have is a very wet winter in Southern California. And with a very strong El Nino event, the most likely outcome for next summer is a developing significant La Nina event. And those events are the kind that tend to result in hotter summers and windier falls. So if we go from very wet to very dry in quick succession, that does start to feel a little bit like the transition from 2024 to 2025 in Southern California because we had really wet conditions in Southern California in early 2024, if you recall, and then record dry conditions in the 6 months following, which preceded the severe wildfire. So this wet to dry whiplash with the vegetation, the grass and brush abundance through growth, and then drying and curing of those fuels with that sequence from wet to dry. Southern California was not in a drought of any significance during the LA fires, you may recall, in 2025, and yet we had this wet to dry whiplash sequence. Could we see something like that again from winter spring 27 going into summer fall 27? That would be something I would be a little more concerned about than what might happen over the next few months. Doesn't mean we won't have significant fires in the next few months. It just means that the likelihood won't necessarily be higher because of El Nino in the short term.
That makes a lot of sense. And these cycles affect us next year without a doubt. I'm also curious because you did mention the fires affecting the Pacific Northwest. We've seen it in so many other parts of the US, Europe this past year. What are the impacts of El Nino on a more national or international scale, if you can comment on either of those?
Yeah, it varies a lot dramatically actually by about California-sized units of aggregation. So I'd probably have to go through a couple hundred of them to get the full international scope. But in general, in the US, the summer preceding a big El Nino event is often not as hot in the Pacific Southwest, including California, is hotter and drier in the Pacific Northwest, which we've seen. But then the more significant effects come in winter, where California, especially Southern California, is more likely to be wet. The southern tier of states, Texas, Florida, Carolina, is more likely to be wet during the winter. The northern tier drier, so the Pacific Northwest and Northeast. In places like Indonesia, often there is a severe drought with heat waves and wildfires. We're seeing that right now, very serious drought and wildfires in Indonesia. We see the potential for a disrupted Indian monsoon. We see potential for drought in southern Africa and floods in eastern Africa. We see potential for drought in parts of Australia, particularly as we go into next year. So, and in the end of the tropical rainforests, potentially in the Amazon. So we see this patchwork of drought and flood and fire-related impacts. It's not all else equal. Some of these are already occurring. Some of them wouldn't even be expected to occur until later because the effects of El Nino are often lagged because the maximum amount of heat coming out of the climate system actually doesn't occur until the dying stages of El Nino. So we're still in the ramping up stages for now. So it's a bit of a mixed bag. But in the terms of the U.S. precipitation impacts, the most significant ones are probably in winter, wetter in California and the Southwest, Arizona, New Mexico, drier in the Pacific Northwest, Washington, maybe British Columbia, wetter in the southeastern U.S. As well.
Hmm. Things to pay attention to. And we have a few questions about kind of, I'm not entirely sure what this is. I'll leave it up to you if you want to answer the blob and the potential of the return of the blob, a phenomena from 2015, and whether these increased ocean temperatures, how they might affect ecosystems or correspond to algal blooms in the
Yeah.
ocean.
So there's a lot of use and misuse of the blob term. You may have noticed that I talked about the blobbiness, if you
Yes.
will, of El Nino in the tropics. That's one blob. I think the blob people are talking about is sort of the one that was associated with the so-called ridiculously resilient ridge, sort of during the California drought back in the 2010s era. And that was actually in a completely different part of the Pacific. That was in like the Gulf of Alaska. And so that was co-located with this high pressure system. Um, the problem with the blobbiness argument is that it actually, so it's the physical meteorology and the physical oceanography of ocean warm blobs is actually really, really complicated. It matters where the blob is in terms of the effect that it has on the overlying atmosphere. So you could move that same warm blob around in different parts of the Pacific, and it would do completely different things to the climate. In some places, it would do almost nothing other than slightly warm the air above it. In other places, it would create massive storms. In other cases, it might create a huge undulation in the jet stream. And so this year, we're almost certainly going to have the opposite of the blob in that particular part of the Pacific. It's likely to be actually a little bit cooler than average, which these days is rare territory because, as we know, in a warming ocean, that's hard to achieve because we expect to see such persistent storminess exactly where the persistent anti-storminess occurred during the drought. During the big, where the big ridge was during the drought, we expect to have a big low pressure system churning up the ocean, keeping it from warming up and keeping it cooler. But instead, what we've got is a really warm water right along the immediate California coast, which is a bit different. This is having already profound effects on ecosystems. There are subtropical species that are already starting to arrive in California right now. It's extremely hot and humid along the Southern California coast. It's like Miami. I mean, and that's not even an exaggeration. It feels like Miami in San Diego and LA this week. It really is humid as well as hot, and that is not typical. This originally earlier this summer didn't really have to do with El Nino. It was a sort of separate marine heat wave, but increasingly now, as we get into late August into the fall, this is going to persist, and it is increasingly associated with El Nino now. So the I don't think that we're going El Nino and its dominant influence from the tropics are really going to be the number one thing we see this winter. It's just it's the I liken El Nino and other climate influences to various voices in a crowded room. And, if you're standing right next to somebody who's speaking at a normal speaking voice conversationally in a crowded room, you'll probably hear them okay. If you're trying to listen in on a conversation across the room where there's 100 people in it, good luck. You're probably not going to be able to hear their voice above the noise. But now, if that person on the other side of the room suddenly grabs a megaphone and starts yelling into it, you're going to hear their voice, even though there's 100 other voices in the room. And that's kind of like what this year's El Nino is doing. Is yes, there are other influences, but it is such an extremely dominant one that I think it's probably going to be the number one factor at play this year.
Wow. Well, while some of our Californians enjoy that warmer than average summer water in the coast, I definitely enjoyed it in Santa Barbara this past weekend, but it was incredibly hot, as you were mentioning. And we all do need to get prepared for what sounds like it may possibly be a pretty wet winter. We are out of time for questions, but I want to thank you so much, Daniel, for joining us today and sharing your expertise. And thank you, everyone, for tuning in. We hope you all enjoyed the conversation. We'll be sending the recording soon in case you missed anything or would like to revisit the discussion. We also, if we have a chance, if there are any lingering questions, may be able to reach out to you with responses in the future. For more information on El Nino and other climate and weather events, please, I highly recommend you follow along on Daniel's blog, Weather West, or find him at Weather West on YouTube, Twitter, and Blue Sky. He had another great video call earlier this week that he shared a lot of the similar information and other interesting facts too. And then also, please also follow Sustainable Conservation to learn more about our work and access all of our webinar recordings. These webinars and Sustainable Conservation's collaborative program work are fueled by generous individual donations. If you enjoyed this conversation, please consider supporting us by scanning the QR code on your screen. We greatly appreciate your attendance, and we really hope to see you all at the next one. Thank you again.